Now let's continue in solving for the standard deviation. So have the sum of the squares. The next one is the sum of the squares. You divide it by n minus 1. So how many entries do we have? Actually, if you don't want to count it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You can all just have count. Let Excel count for you there. We have 19. Why am I verifying it with Excel? Because sometimes danghag ko mag-count. So I want to verify it with this one, with the formula. Again, the formula is count equals count. So let's go back to the sum of the squares. So equals the sum of the squares, this one, you divide it by n minus 1. Again, let me correct it. N minus 1, not only n. So that will be 19 minus 1. It's already 18 here. The answer to that, let's decrease it into decimal places, is what we call the variance of the data. If we want to solve for a standard deviation, that is the square root of the variance. So what's the command? The command is SQRT. So equals SQRT square root. Again, start with the open parenthesis, select your data, close parenthesis, enter. So here, decrease, that will be for the standard deviation. So our standard deviation is 6.28. You know how to do it? Remember, our mean is 86. You add 6.28, that will be our first standard deviation in our stat class. You add another 6.28, that's the second standard deviation. Now, why am I teaching you this lengthy one? Because modular students, you really need this as you complete your module. This one, this table. But for modular students, it's okay with me if you'll do it in Excel. For example, you do it in Excel and you print it, no problem. Or you want to do it in Excel and you will just write the answers, no problem. I'm providing you an easier way to answer it, rather than do it manually. But here's the way to check it, especially with online distance students. You can solve a standard deviation without doing the whole table. Why am I saying? Why am I teaching you the whole table? Because your workbook tells you that to show your procedure. But here's the easiest way to do it. So variance and standard deviation. The easier way to do it is to use the command. For variance, the command is var. For standard deviation, the command is stdev. So for variance, equals var, open parenthesis, select all your GPAs, close parenthesis, enter. There. It's just the same, right? It's the same with the lengthy method we had a while ago. Next, standard deviation equals stdev. That's the command, equals stdev, open parenthesis, select all your data, close parenthesis, enter. Decrease the number of decimals. So do not tell me you'll analyze your data with using only a calculator? No. We use a higher advanced technology, even if it's Excel. We even use a more advanced technology with this one. So standard deviation is 6.28. The same with the previous one. Okay, so ma'am, if I'll use descriptive statistics, what do I usually report? You report the mean and the standard deviation. That's it. Now, let's go back to our presentation. Hope it's clear with you. Now, the next one, so here's the method presented in your module. Let's go to advanced quantitative analytical methods. I'll teach you more of this next meeting on how to do it using Excel and also using SPSS, or dapat abbreviations should be said. The statistical package. Okay. Now, there are three basic ones. You have the correlation if you are dealing with relationships, Anova, and regression. Now, how are these three different? For example, correlation is a statistical analysis method you used when you check the relationship of the two. For example, you check the relationship of the attitude towards math and also of the academic performance. You just check the relationship. Therefore, it is under the correlation data analysis technique. Now, when do we use Anova? Let me use my pen first. Give me a moment. Last time, I guess last week, I shared to you the different statistical techniques, right? Now, when do we use Anova? For example, actually Anova is a repeated t-test. Let's start first with t-test. Paired t-test. When do we use paired t-test? When you compare the before and the after. Example, your study will be the effects of lemon juice on weight loss. How do you know it's effective? Timbang before, compare, inom dayon og lemon juice, timbang after. So we compare our mass before and after. If we do that, then it's paired t-test. Another is the independent samples. I always forgot the samples word. Paired samples t-test. Independent samples t-test. Example. One group with treatment, another group without treatment. Then test. We compare the two. Example, one group of Hmong beings are listening to rock music. Another group is listening to classical music. Then we check their weight, their mass. Mass of the rock music group Hmong being and mass of the classical music Hmong being. Then you compare the two. You use independent samples t-test. Or for reading comprehension, reading comprehension of group 1 while listening to classical music, and reading comprehension of group 2 while reading without any music. Compare the two. That's independent samples t-test. When will we use Anova? When there are more than two groups. Example, let's add another group. Okay. Group 1 is reading comprehension while listening to classical music. Group 2 is reading comprehension while listening to rock music. Group 3 is reading comprehension while reading but without any music, no music. You compare the three groups, the reading comprehension of the three groups. What is our statistical technique? That's analysis of variance or Anova. The last one is regression. Regression is very similar to correlation, but here's the keyword: predict. In regression, we check if the variable is a predictor of another variable. Example, let's have series of correlation, okay? What will affect academic performance? I'll check. Is it attitude? Correlate with academic performance. Will it be student engagement, kung unsa ka participative ang student sa klase? Will it be sleep quality? So here, what you're doing is only series of correlation. Relationship number 1, relationship number 2, and relationship number 3. But in regression, we are asking, among the 3, which one will predict academic performance? It's possible that na ay relationship si sleep quality and si academic performance, but possible nga dili siya predictor. It means it will never be a basis, or it can never predict your academic performance. Possible that attitude has a relationship towards academic performance, and it is also a predictor of academic performance. Whether the prediction is towards positive relationship or negative depends on your correlation. So usually when we do regression studies, we also do correlation, because our question is it a predictor? Yes or no? Yes. Is the prediction towards positive, like kung taas og sleep quality, taas po og academic performance, or negative, kung mubo og sleep quality, taas og academic performance, kinabilan og study? Then it's correlation who will answer it. So if you do regression, you also do correlation. So that's the end for our quantitative data analysis. I'll give more in-depth statistical methods